In this video we're going to take a look at another example of using the present value function in Excel. In this case what we're going to do is we're going to look at the lottery problem. Whenever somebody wins a lottery, if you win a $20 million lottery, for example, you don't actually get $20 million. What you get is you get that $20 million paid off over a period of time. So you usually have the option of either taking that amount over a period of time, or you can take a lump sum today, which is considerably smaller. And so the problem we're trying to solve here is, how do you decide whether you should take the lump sum or whether you should take the $1 million a year over 20 years. And it all depends on what you think the interest rate is that you could earn on that lump sum. So here's what we're trying to figure out. We're trying to figure out, if we took the lump sum and we put it in a savings account and we earned 6% on it for 20 years, and at the beginning of every year we withdrew $1 million, just like we would if we were taking the other payment choice in the lottery, would we have enough money to withdraw $1 million per year while still earning 6% on that remaining balance? And if the amount of the lump sum allows you to withdraw $1 million a year and still have some left over at the end, then you should take the lump sum. If you run out before 20 years, then you should probably take the $1 million a year. So this is what we're trying to figure out here. We're trying to figure out what the beginning balance is, what the lump sum payment should be, and we don't know that. But we know we're going to withdraw $1 million every year, and we're only going to do it once a year. So this is one of those rare problems where we're not doing monthly calculations. So the number of periods per year is going to be 1. The number of years is going to be 20. The annual interest rate, I think, is going to be 6%, and the ending balance is 0, and that's formatted wrong. That should be formatted like this. And the number of periods, we can do a formula here. It's going to be the periods per year times the number of years, and the rate per period is going to be, and again in this case really don't need those formulas, but if these numbers would change, then we wouldn't have a problem changing the formula. We could just go in here and change the numbers, and our balance would automatically be updated. And we're going to do these payments at the beginning of every year. Okay, so that's the information. And then what we need to do over here is we need to use the present value function on financial here. Scroll down to the letter P, and there's PV. And we need to tell, what's the rate going to be? Well, the rate is going to be the rate per period, which in this case happens to be the annual rate, but that's usually not the case. The number of periods is here, and again that's the number of years, but that's usually not the case. Payment is always a negative number, and that's how much we're going to withdraw every year. Future value, we want it to be 0 when we're done, and the type is going to be this. And if we click on OK, it tells us that if we had $12,158,000 and $116.49, and we withdrew $1 million right away and kept that money invested at 6%, and then withdrew $1 million next year and still kept investing the money, at the end of 20 years we would have exactly 0 left. The amount to withdraw at the beginning of that 20th year would be exactly $1 million. We'd withdraw the $1 million and we'd have a balance of 0. So if 6% is the interest rate you think you can earn, and the lottery offers you more than $12,158,116, then you should take that. On the other hand, if they offer you less than that, then you would probably be better off taking the $1 million a year.